The most difficult part in 3D trigonometry is about the angle between two planes. So they are asking there is a point on AD, and then someone which is called K, and then B to K perpendicular to AD. This is point K, and then someone claimed that angle BK to C, that angle is meaning the angle between the face ABD and ACD. Do you agree? So some short revision. Whenever we're talking about angles between plane, we need to use a line to represent that plane. So we use the perpendicular line to the intercept line here. Two faces are connected by AD. So BK, which is perpendicular to this line, is used to representing face ABD. Now the key point is whether CK also able to represent the face CDA is the problem. I can tell you that the answer is most probably not. Usually, to make this make sense, one very strict requirement is they are symmetric figure. But the key point is if you really draw a perpendicular line to AD, then they do not cross at point K. It's nonsense that it must be point at point K, right? So most probably this is another point, maybe called H. And your mission to prove that it is not the angle, you need to prove H and K not at the same point. They are not at the same point. But how can you prove that? Of course, it's difficult to understand in this way. So we need to create a net. This is 3D diagram. I need to, no need to consider CB now because we are just talking about these two faces. And then we need to create a net, 2D net. I put AD first, D and A. And then you may consider this is a paper flow in this way. And then this is the left ring, this is the right ring. Left ring maybe it's look like this. Right, this is C, 27. And then the right ring maybe it's like this. We already know that they say that K is somewhere here because it is perpendicular. And then we need to prove that there's another point, maybe called H. We need to prove that H and K are not the same point. To do this, the best method, this is 65 degrees, and then DB, if we want, we can find that out. Or we already got this one, 16 point, AB 16.03047.854. We may just simply compare this length with this length and see whether they are the same. If they are not the same, that means they are not at the same point. So what I want to do is quite obvious now. This I just briefly explain how to do. This is 27 and then this is 15. The length here is 15. CA, we already know that AC is what we got in part A, is 28.016145565. So by doing this, you can use cosine formula to get this angle. After you get this angle, by using this right angle triangle, you can find DH. Similar reason, you may get the length of DB, and then you get this angle because this is 58 degrees. So you may easily find out this angle is 57 degree. And then so you use cosine 57 degree times this one, and then you use 15 minus it, then you can get this length. you'll find that these two lengths are not the same, so you prove that it is not the angle between two faces.